Good evening students. I am MRS.K.DEVI, Assistant Professor of Computer Science, A.D.M. College for Women, Autonomous, Nagapattinam. Now I take the topic of operating system. Introduction. What is operating system? Computer system organization, computer system architecture, operating system structures, operating system operations, process management, memory management, storage management, production and security, kernel data structures, computing environment, open source operating system. First of all, what is operating system? A program that acts as an intermediate between user of a computer and the computer hardware. Operating system goals: execute user programs and make solving user problem easier. Make the computer system convenient to use. Use the computer hardware in efficient manner. Computer system structure. Computer system can be divided into 4 components. First one is hardware. Hardware provides the basic computing resources. Example: CPU, memory, I/O, input and output devices. Second one, operating system. Controls and coordinating use of hardware among various applications of users. Next one, application programs. Define the way in which the system resources are used to solve the computing problem of the users. Word processor, compiler, web browsers, database systems and video games. The last one is user. Examples: people, machines and other components. They are the computer system structures. Next one is the example of the computer system structures. First, user, compiler. Compiler means the find out the errors. Assembler, combining all the program to the executable programs. Text editor, to find out the some documents. Database system, to collecting the informations through the user. The operating system do depends on the point of view. User wants to convenience, easy of use and good performance. Don't care about the resource utilizations, but share computers such as mainframe or mini computer. Must keep all the users happy. User of dedicated systems such as the workstations have dedicated resources but frequently use shared resources from the server. Handheld the computers are resource poor, optimized for the usability and battery life. Some computers have little or no user interface, such as embedded computers in device and automobiles. Operating system definitions. OS, operating system, is a resource allocator, manageable all resources. Decide between the conflicting requesting for efficient and fair resources use. OS is a control program. Controls execution of program to prevent error and empower use of computer. Operating system definitions or continuation. No universal accept definitions. Everything a vendorship when you order on computer system is a good optimization, but varies widely. The one program running at all the times on the computer is the kernel. Everything else is either a system program or an application program. Bootstrap the program is loaded at power up or reboot. Typically stored in RAM, read-only memory, or EPROM, erasable programmable read-only memory, generally as known as fireware. Next, initialize all the aspects of systems. Loading, operating system kernel and start execution. Computer system organizations. Computer system operations. One or more CPUs, device controllers connect through common bus providing access to shared memories. CPU is the brain of the computer. The disk controller controls all the device of work. Memory is the two type, RAM and ROM. Next, USB controller. The USB controller, the mouse, keyboard, printer. The graphics adapter means the monitor. Computer system operations continue. Input-output device and the CPU can execute concurrently. Each device controller is in charge of a particular device type. Each device controller has a local buffer. CPU move data from main memory to the local buffer. Input-output is from the device to local buffer of controller. Device controller informs CPU that it has finished its operations by caching an interrupt. Common functions of interrupt. Interrupt transfer control to the interrupt service routine, generally through the interrupt vendor, which contain the addresses of all the service routines. Interrupt architecture must save the address of the interrupted instructions. A strap or execution is a software generated interrupt caused either by an error or the user request. An operating system is a interrupt driven. Interrupt handling. The operating system preserves the state of the CPU by storing registers and the program counter. Determines which type of interrupt has occurred. Polling and vendor. Interrupt system. Separate segment of code determine what action should taken for each type of interrupt. The interrupt timeline is given. After input-output start, the control return to the user program only upon input-output completion. Wait instruction idle the CPU until the next interrupt. Wait loop, the connection for memory access. At most, one input and output request is outstanding at a time, no simultaneous input-output process. After input-output starts, control return to the user program without waiting for input-output completion. First one, system call. Request to the operating system to allow user to wait for I/O completion. Device status table contain entry for each input-output device indicating its type, address and states. Operating system index into input-output devices table to determine device status and to modify table entry include interrupt. Storage structures. Main memory. Only large storage medium that the CPU can access directly. Random access memory, typically the volatile memory. Secondary storage. Extension of main memory that provide large non-volatile storage capacity. Hard disk. The mantle of glass platter covered with magnetic regarding materials. Disk surface is locally divided into tracks which are subdivided into sectors. This disk controller determines the logical interaction between the device and the computer. Next one, the solid state disk. Faster than hard disk, non-volatile. Various technologies and becoming more powerful. Storage hierarchy. Storage system organized in hierarchy. The first one is speed, second one is cost, third one is velocity. Caching. Copying information into fast storage system. Main memory can be viewed as a cache for secondary storage. Device driver for each device controller to manage input-output. Provides uniform interface between the controller and kernel. Device storage hierarchy picture is showable. Caching. The important principles performed at many levels in a computer. The information in use copied from the slower to faster storage temporarily. Faster storage, the cache checked first to determine if information is there. If it is information used to directly from the cache. If not, data copied to cache and used there. Cache smaller than storage being cached. Cache management important design problem. Cache size and replacement policy. Direct memory access structure. Used for high-speed input-output device able to transmit information at close to memory speed. Device controller transfer block of data from buffer storage directly to main memory without CPU intervention. Only one interrupt is generated per block rather than the one interrupt per byte. How the modern computer works. Show the picture. Computer system architecture. Most systems use a single general purpose processor. Most systems have special purpose processor as well. The multi-process system growing in use and importance. Also known as parallel system, tightly coupled system. Advantages of computer system architecture. Increased throughput out. Economy of scale. Increased the reliability. The two types of multiprogramming. Symmetric multiprocessing. Each processor is assigned a specific task. Asymmetric multiprogramming. Each processor performs all the tasks. Asymmetric multiprocessing architecture is given. A dual core design. Multi-chip and multi-core. The system contains all the chips. Just contain the multi-separate system, clustered system, like the multiprocessor system, but multiple systems working together, usually sharing storage via the storage area network, means SAN, providing a high availability service which survive the failures. Asymmetric clustering has one machine in hot standable mode. Asymmetric clustering has the multiple nodes running applications monitoring each others. Some clusters are for high performance computing. Applications must be returned to use the parallelism. Some have distributed lock manager to avoid the conflicting operations. Cluster system diagram is shown. Operating system structures. The first one is multiprogramming. This means the batch system. Need for efficiency. A single user cannot keep CPU and input-output device busy at all the times. Multiprogramming organized job so CPU always want to execute. A subsystem of total job in system is kept in memory. One job is selected and run via the job scheduling. When it has no weight, operating system switches to another job. Time sharing. This means the multitasking is a logical extension in which CPU switches job so frequently that user can interact with each job while it is running, creating the interactive computing. Response time should be the 1 second. Each processor have at least one program executing in memory. This means process. If several jobs ready to run at the same time, this means the CPU scheduling. If process do not fit the memory, this means swapping, moves them and out to run. Virtual memory allows execution of process not complete in the memory. Memory layout for multi-programmed system. The operating system allocated for 4 jobs. Job 1, job 2, job 3 and job 4. The total memory is 512. The operating system operations. Interrupt driven, the hardware and software. The hardware interrupt by one of the device, the software interrupt exception or trap. Software error is the division by 0. Request for operating system service. Other process problem including infinite loop process modifying each other or the operating system. Operating system operations, the dual mode operation allow operating system to protect itself and other system components. User mode and kernel mode. Mode bit provide the hardware, provides availability to the when the system is running user code or kernel code. Some instruction designed as the privileged only executable in kernel mode. System call changes mode to kernel. Return from the call reset into the user. Increasingly, the CPU support multi-mode operating system, that is the virtual machine manager mode for guest transformation user to kernel mode, the timer to prevent infinite loop, the process logging resources. The timer is set to interrupt the computer after some time period. Keep a counter that is decremented by the physical clock. Operating system set the counter. When the counter 0 generated an interrupt. Process management. A process is a program in executions. It is a unit of work within the system. The process needs the resources to accomplish a task. CPU, memory, and input-output files. Process termination requires the reclaim of any reusable resources. Single. The thread process has one program counter specifies the location on next instruction to execute. The multi-thread process has one program counter per thread. Typically, the system has many processes, some uses some operating system running concurrently on one or more CPUs. Process management activities. The first one is creating and deleting both user and system process, suspending and reusing the process, providing mechanism for process synchronization, providing mechanism for process communication, providing mechanism for deadlock handling. Memory management. To execute program, all of the instruction must be in memory. All of the data that is needed to by the program must in the memory. Memory management determine what is memory and when. Optimizing CPU, utilizing the computer resources to the user. Next, the memory management activities, keeping the track of status, determining the policy and allocation and deallocation. Storage management. The operating system provides the uniform logical view of information storage. Abstract, the physical properties or logical storage unit of files. File system management. The file usually organized into directories. Access control on most systems to determine who can access what. Operating system activities including creating and deleting, primitive to manipulate the files, mapping files on the secondary storage, backup files. Mass storage system. Usually disk used to store the data that does not fit in main memory. Proper management is of central importance. Entire speed of computer operation hiding the disk subsystem and its algorithm. Operating system activities. The first one is free space management. The second one is storage allocation. Third one is the disk scheduling. Some storage need not to be fast. Still must be managed by the operating system or applications. Varies between the write once, read many times. Input output subsystem. One process of operating system to hide the of the hardware device from the user. I/O subsystem responsible for the memory management. The general device driver interface driver for specific hardware device. Protection and security. Protection. Any mechanism of controlling access of process or user to reuse the defined of operating system. Security. Defends the system against the internal and external attack. Systems generally first distinguish among user to determine who can do what. User identities. It means the user ID, security IDs include the name, associated numbers. User ID they associate with all files. Group identifiers also set of users to be defined the control management of process files. Previous escalations allows user to change to effective IDs with more rights. The kernel data structure is displayed. This is the combined with the linked list. First one is linked list is 3 types. The first one is single linked list, second one is double linked list, third one is the circular linked list. Computing environments. Handling the smartphones, tablet, etc. What is the functions difference between them? The traditional laptop. Extra features more the operating system features. Allow the new type of app like the reality. Leaders are the Apple iOS and Google Android. Distributed computing. Collecting of separated, possibly the heterogeneous systems networked together. Network is a communication path, the TCP/IP, Transmission Control Protocol, Internet Protocol. Most common, local area network, wide area network, metropolitan area network, personal area network. The network operating system provides features between the system across the network. The communication schemes allow system to exchange message. Computing environment, client and server technology. The client and server computing, dumping the terminals by these smart PCs. The computer system servers provide an interface to client request service, that is the database. File server system provide interface from client to store the retrieved files. Cloud computing environment composed of traditional OS plus cloud management tool. Internet connectivity requires the security like firewall. Real-time embedded system most prevalent from the computer. Very considerable. Special purpose, limited purpose OS, the real-time OS. Use expanding many other special computing environment as well. Some have the OS, some perform tasks without an OS. Real-time OS has well-defined fixed time constraints. Process must be done within constraint. Correct operations only if constraints meet. Operating system made available in source code format rather than just binary. Counter to copy protection and digital rights management. Started by the Free Software Foundations. Examples include the GNU and Linux and BSc Unix. And many of us can use the VMware player, VirtualBox and many platforms used to run guest operating system for exploring. Thank you.